Hello everyone, this is Dr. G. Karthik Reddy, working as Associate Professor in the Department of EC, MLR Institute of Technology, Hyderabad. Today's session topic is problems on jointly wide sense stationary random process. Okay. In this session, we are going to discuss what is the definition of jointly wide sense stationary, and we are going to discuss problem related to the jointly wide sense stationary random process. Okay, first of all, what is jointly wide sense stationary? Okay, jointly wide sense stationary tells that, okay, the condition of the jointly wide sense stationary, okay, it must be satisfied. Okay, for example, let x of t and y of t be two random process. Let x of t and y of t be two random process. Then the expectation of x of t must be constant. Okay, the first condition is the expectation of x of t must be constant. Okay, the constant x bar, or you can also write constant, or it is independent of time t. Now, second condition tells that expectation of y of t must be constant. Okay, must be constant, that is independent of time t. Now, third condition tells that the cross correlation function, that is rxy of tau. Okay, rxy of tau means, okay, that is cross correlation must be function of time difference, or tau means the difference of two time instants of two different random process. Okay, this must be, okay, this is a formula, expectation of x of t into y of t plus tau. Okay, it must be here also independent of time t only. The stationary process tells that it is independent of time t, but here it is dependent on tau or time difference. Okay, if all the three conditions are satisfied, then the given process is said to be jointly wide sense stationary. WSS represents wide sense stationary, or you are having one more terminology that is also called as weak sense stationary. Okay, here in this case, jointly wide sense stationary, we are calculating up to the second order process only. Okay, that is why it is called as weak sense stationary process. Okay, we are taking the approximation to the original random process. Okay, based on these parameters, we can judge that whether it is satisfying jointly wide sense stationary or not. Okay, you can have some clear thought by solving the problem related to this concept. Okay, the problem related to jointly wide sense stationary. Okay, you are having x of t and y of t are two different random process. Okay, expectation of x of t equal to 5. Okay, if you are getting the problem like this, okay, you are getting the answer, expectation of x of t is 5, expectation of y of t is 3. Some constant value, whatever the constant value, okay, these constant values will not be depend on time t. Then this is called, okay, it is satisfying the first condition. Expectation of x of t is constant. Expectation of y of t is also constant. Okay, if you are getting the like the similar answers, then the first two conditions are satisfying. Then the autocorrelation function. Okay, autocorrelation function, it is given that rxx of tau. Okay, autocorrelation rxx of tau is equal to 4 into expectation to the power of minus mod tau. Next, ryy of tau, it is given as 3 into expectation of minus mod tau. Okay, here he given the autocorrelation function in the given question. Okay, next, okay, here autocorrelation is also independent of time t, it is depending upon tau. Here also it is depending upon tau or time delay. The cross correlation function rxy of tau is equal to 2 into exponential to the power of minus mod tau. Okay, mod tau. Okay, all these three, okay, here it is having the independent of time t, expectation of x of t and expectation of y of t, both are independent of time t. Autocorrelation function, here also the autocorrelation function of x of t is independent of time t. Autocorrelation function of y of t is also independent of time t. The cross correlation function. The cross correlation function is also independent of time t. Okay, based on the condition, you can check it and you can verify. This is a shortcut. Or if you want, you can solve the problem. Verify x of t and y of t are jointly wide sense stationary. Here they are given the condition. Okay, we have to solve this one. Okay. Now next, check that. Just now I discussed the solution. Okay, x of t and y of t are jointly wide sense stationary. The means of x of t and y of t are constant over the time, satisfying the criteria of wide sense stationary. Okay, next, autocorrelation Rxx of tau and Ry of tau or Rxy of tau all are depending upon the time difference tau and satisfying the second criteria condition. Then the cross correlation is also depending upon tau. Tau represents what? Time difference. Time difference between two process. Okay, this is one of the random signal. This is the second random signal. Okay, this is x of t. X axis is time t, y of t. Okay, this is a time instant t1. This is a time instant t2. Okay, t2 is equal to t1 plus tau. Tau is equal to t2 minus t1. Tau is equal to t2 minus t1. The difference of two time instants of two different process. Okay, it is depending upon time t and but not on absolute time. Okay, if both the conditions are satisfying, then x of t and y of t are said to be jointly wide sense stationary. Jointly wide sense stationary. Okay, we'll solve one more problem. First problem is just for understanding purpose I have given that. Now second problem. Okay, x of t and y of t are said to be jointly wide sense stationary. Their autocorrelation and cross correlation function is given. Show that cross correlation function depending upon the time difference and satisfying the inequality of them. Okay, we'll solve this problem. Okay, they are given that with the definition, expectation of x of t, which is equal to mu of x or x bar, that is mean, ergo mean part, mean is constant, mean of x of t is constant, mean of expectation of y of t equal to u of y, here it is also the constant. Then Rx of t1 comma t2 represents autocorrelation of x of t for the time instance t1 comma t2, or we can also call the time difference Rx of t1 minus t2. Okay, and next similarly autocorrelation of y of t. Okay, Ry t1 comma t2, Ry t1 minus t2. Then Rxy, this is a cross correlation of x of t and y of t at time instance t1 comma t2 or difference t1 minus t2. Okay, then this implies Rxy of tau, which is equal to Rxy of tau means expectation of x of t minus x bar, y of t plus tau minus y bar. Okay, this is a basic standard definition of cross correlation function. Now next, the time invariance. Okay, here he is telling that to satisfy the cross correlation function independent of time t with the help of the inequality condition. Okay, by definition of jointly wide sense stationary, we know that it is independent of time t. Okay, independent of time t, then you are going to get Rxy of tau. Tau is equal to difference of two time instants, either t1 minus t2 or t2 minus t1. Okay, it is depending upon tau and it is independent, or not on t1 and t2 independently or individually, it is not depending the function. Next, the inequality tells that what is the inequality condition. Okay, we solve this one in the one of the properties of cross correlation function, which tells that mod Rxy of tau, which is equal to square root of autocorrelation of x of t at tau, at t tau equal to 0. Next, autocorrelation of y of t at tau equal to 0. Okay, if this condition is satisfying, then it is called inequality condition is satisfying based on this condition, where Rxx of 0 and Ryy of 0 or the autocorrelation at 0 lag of x of t and y of t. Okay, if the condition is satisfying, then the cross correlation is satisfying. Okay, condition is that this condition, here we discuss that condition of this, the cross correlation condition is tau square. Okay, Rxx of 0. Okay, we substitute the Rxx of 0 at tau equal to 0. Okay, we substitute the tau equal to 0. Then if we can substitute the tau equal to 0. Why you are taking Rxx of 0 at tau equal, okay, at tau equal to 0 means at tau equal to 0 autocorrelation you are going to get the maximum. Okay, autocorrelation is maximum at tau equal to 0. If you are taking x-axis as tau, y-axis as Rxx of tau, the maximum value of the autocorrelation function is satisfying at, okay, maximum value you are going to get, the optimum unimodel you are going to get at tau equal to 0. At tau equal to 0 you are going to get the maximum value. Then the product of this is equal to cross correlation function. Okay, then here we are not having any time lag. Okay, it's substituting at tau equal to 0 time lag. Next, the product, this is also called as the geometric mean. The geometric mean of these two conditions. Geometric mean, the square root. Geometric mean means A, B, C you are having. The geometric mean B is equal to square root of A into C. Okay, here A into C represents Rxx of 0 into Ryy of 0. Okay, here the condition is satisfying. Then it is also satisfying the inequality of that condition. Okay, these are the problem related to the joint, wide sense stationary. Okay, how to solve the joint, wide sense stationary? You have to satisfy all the three conditions. We discussed that mean of x of t must be constant, mean of y of t must be constant, that is independent of time t, and the cross correlation function must be independent of time t. It is depending upon the time difference or tau. Okay, then only it is satisfying the stationary or, okay, here we are having two x of t and y of t, two different process. That is why it is called as jointly wide sense stationary condition.